A lesson we learn improving productivity and performance, and we have two lessons for that, and I call it improving productivity and performance 1 and 2. So for the 1, we have 4 learning objectives. The first, we explain the data gathering techniques in improving productivity, prepare necessary forms for direct field observations, including productivity ratings, crew balance chart, and for years you will apply this concept in your semester project. And then the third objective, we analyze factors affecting humans and the workers in construction, and then evaluate the learning curve effect. So let's first the first portion of class for here. For that, this lesson, we talking about the improving productivity and performance. We need to differentiate what is the difference between productivity and performance. So for performance in this class, it's all aspect of construction processes, and productivity is one phases, one aspect of the performance. So when we say performance, for example, on-site performance, that is the target, the goal that we try to achieve today is including productivity, safety, timeliness, quality. And of course, in nowadays, you can add more aspect on the performance of the on-site operations, such as sustainability, resiliency, all of that. We can see its performance. And productivity is one of the indicator for the performance. So that now you see the difference between performance and productivity, especially applied for this class and these lessons. To go overview of what is the on-site performance or operations relative to the whole project lifecycle that you learn in project planning, and I show this diagram so that you can see what we are focused on today lesson, and most of our material covered in this class. So you see the party involved in the construction process, start with the owner or client, and then we have designer, architect, engineer, multiple type of engineer, environmental, civil, electrical, all of that. And then when the engineer come up with design, we have plan and specification. Owner have to come up with the financing, where the money, get the permit with the support of constructor and designer. And then we find the constructor to do, and the constructor supply resources. And for the resources, we mean the commitment, materials, information, working space, staffing, method, equipment, and tool. All of that is the resources provided to conduct the project. And all of this planning process that we focus on in the project planning, and that is away from work phase. And now on site, so at the work phase, that's what we focus for this class, is including the products, the physical products for the project, such as the roofing, the concrete column, or the mechanical system, air conditioning system, electrical system in the project. All of that is the products that we are talking about, and it needs effort and skill. And where that come from? It comes from all the resources here, including crews and the foreman that supervise the crew. So that's what we focus in this class, and also, of course, today for performance and productivity improvement, we also focus on at the work phase, at the on-site operation. And just to show you an overview about the productivities and what are the factors improving or reducing the productivities, and that there are multiple factors. And with that, I show you this idea, basically a map that show at the end, this is the reduced productivity. It can be from many factors involved. The major rework, something we have to redo, demolish, redo it, that will reduce productivity or improve, increase in the inefficiencies. And then slow work slow, traveling, back and forth, waiting, or idle work, So we just stay, supposed to work, but we stand there waiting for the work, waiting for instruction. All of that consider reduced activities, and that affect many factors affecting those major factors. For example, the rework, you have a damage, you have a poor quality of work, the work that conducted does not meet the specification as stated by the designer or specification. So all of that will affect the productivities. And then to improve productivities, how we can get away from the reduced productivity, we need to have approach to improve. And what are the approaches improve productivities, and what are the processes involved? First, we need a data. Data is key. We need to have a data. So have a data gathering technique, and then we have a tool to analyze the data so that we see what are the issues, what are the potential for improvement, and then then we have a problem. We can have a technique to have a problem solution techniques, and then we can implement our solutions or other technique to improve productivity. And then of course we go back to gather the data to see whether our solutions really improve productivity, what's went wrong, what go correct. All of that, it can be in this process, and it will be iterative process for continuous improvement. So let me discuss all of this that we can apply specifically for our class and our semester project. First, talk about the data gathering. In terms of data gatherings, of course, that we need to have some statistical aspect of data gathering. It needs to have some knowledge about that you learn from statistical method. And then what are the shortcut ways to improve productivities from the data we have, what can be done to improve. And then we have a questionnaire. It can be one tool to get the data, to get what are the people on site think about their operation, how can they think they can work, they can improve their processes, their tasks, their activities. And then the other technique for data gathering, we call activity sampling. And for activity sampling, it can be field ratings, productivity ratings, or 5 minutes rating. And that all have it in the readings for today's class that you can find on Canvas. We have 2 chapters to read, and that discuss very detailed on of this. And then of course, recording present work phase practices, record video recording, on of that to see how it goes. So let me focus on the first statistical aspect of data gathering, and then we focus on one activity sampling that is productivity ratings for this class. Of course, for the further detail, you can read in the book. I just go overview on up here with the first statistical aspect. So we talk about the activity sampling, and we need to see what is the sample size. And in the book, we have a finger. In the reading for today class, we have the finger that shows the sample size, category proportion, and the limit of error and confidence for confidence level at 90% and at 95% confidence level. And how we determine the sample size, because we go out to observe the site, we want to know how many samples we need so that we meet the confidence level that we want to. And if you read more detail in the readings for today class, it normally in construction, the proportion, category proportion, it range somewhere between 40 and 60%. And they say here the range of construction labor proportion. And the confidence level is better to put at 95%. And for the limit of errors, plus or minus 8%, it suggested at 5%. So with that, recommended parameter to determine the number of sample size, and this is the equation to determine the number of sample size in here. If we select it 50% for category portions, it means that it the working activities relative to the whole activity of the construction operation. And then at the 5% limit of errors, then we can draw a line. We can draw a line between the 50% here to 5%, and then go down to there, and whatever it intersect at this point, that we have a sample size, so the number of observation and capital you need. So with that here, it's about 384 samples, and that you keep that in mind when you do for your semester project. We need 845 observation for the field observation when you do productivity rating. So with that here, we go to productivity rating. For productivity rating, we can classify for any given work, any person, any crew members on the work by one of the three, whether he or she do the effective work, whether he or she do the essential contributory work, or not useful work, or idle, in this case non-productive. So basically, whether at any given instant when you look at crew members, the workers, you can see whether he or she is effective or do the contributory work or non-productive. In this case, we say not useful work or idle. And the question comes is, how can I know when I observe certain people that is effective work or contributory work or useful or idle? So idle is easy. When you see someone don't do anything, stay there. If they supposed to do the work idle, then it easy too. But what are the difference with the effective work and contributory work? The form in this lesson that you find on Canvas, and of course I show here, classify what are productive work or effective work, what are the contributory work, and what is the non-productive work, so that corresponding to three categories for productivity rating that I show it in here. So effective or productive work, contributory work, not useful or idle, we call it non-productive work. So what are the activities considered productive work? First, participating in an active physical work. So they actively, directly deliver, put together to finish the product. For example, lay in tile, lay in pipe, put the ceiling on for the work, set up the formwork, place concrete. All of that is participating in active physical work. Adding to the unit being constructed, put a brick on the wall, so that it add in a unit being constructed. Put a roof, a shingle on the roof. Measure the floor before they put the brick on or put the paver on, so that consider productive work. So when you look at crew members, if you see he or she doing any of these three, we consider that productive work. So that with observation, you can put in the project that you observe, observer, your name, any remark about weather, about the time of work, observe date, and then you can have the observation, and then random time, you can just look at people and then see how it works, tick in there, tick, and keep doing like every 15 second or 20 second or 30 seconds, so that you can easily to generate a lot of observation for one worker, let alone in the crew there are many workers in. Now go back to the time of productivity rating. This next one is contributory work, and in the contributory work there are many sub work involved in that. The first one is handling material at the workstation. Very important. If it's the workstation here is the goal that you build, and then you just bring the material, in this case the mortar or the brick, to that workstation, then it considered contributory, not productive work. But if you handling material far away, how far away? 30 feet away, etc. You can read in the book that they define, or 100 feet away from the workstation, then even they handle the work that consider non-productive. So as you can see, at the workstation, if you handle material far away from the workstation, that consider non-productive. Giving instructions For example, the foreman give instruction to crew members how to do the work. That is contributory. Receiving instruction, then the crew member receive instruction from the foreman to make sure they do correctly. That is contributory work. Reading plan or drawings to see whether we put the brick here or put the paver on the other side. All of that is considered the contributory work. Moving within workstation. So moving within the workstation, contributory. So you move around in the workstation, you turn out to break the brick, put it in here. You haven't put it, add in the brick, a unit being constructed yet, but you move around to get the material, even it empty-handed, but it within the station, it's in a short snapshot, then it considered contributory. Move around to get material, etc. Clean up. After the work, you clean up, that contributory. Now, for non-productive work, wait jobs. Someone just standing, wait for the other people do the work, and then continue their work. That is non-productive. Working empty-handed, that for sure. You just work on the site. I will show you a few video later on to demonstrate all of this. Break, take break, also non-productive work. And correcting an error, so do something I showed earlier, something factor that affect the efficiency of productivities, including reduce productivity, that either rework is one of them. You correct error, something damage, or something that you do or the crew members do that does not meet the specification, so you have to correct in the error. So all of that consider non-productive work. So that by now you should be able to know what are the difference between the productive work, contributory work, and non-productive work, and that we do for productivity rating and have a form available in there.